Alright, so in the previous video we talked about multilayer perceptrons and that they can help us with more complex decision boundaries. So in this video we are going to take a look at the architecture behind multilayer perceptrons. For that, consider the Softmax regression model, which we covered previously in Unit 4. And the only big difference between the Softmax regression model and the multilayer perceptron model is that we insert these hidden layers here. The stuff here on the left hand side stays exactly the same. And also all the stuff here on the right hand side, that is the Softmax activation and the Arcmax, stay exactly the same as well. Yet to make it more clear how the multilayer perceptron architecture looks like exactly, let's take a look at the ball and stick model representation of logistic regression. So here we have a logistic regression model with two input features. Now here we modified the logistic regression model to Softmax regression, where we have now 3 output nodes in the output layer. And then when we go from the Softmax regression model to the multilayer perceptron, we insert the hidden layer between the input layer and the output layer. Here we only have one hidden layer, but of course we could have an arbitrary number of hidden layers, and we will come back to this topic later. So as you saw in the ball and stick representation, a multilayer perceptron is a fully connected neural network. Fully connected here means that each node in one layer is connected to each node in the next layer. It's also a feed-forward neural network because the information flows from one side to the other, from left to right, and it doesn't flow backwards. So this is why we refer to a multilayer perceptron as a fully connected feed-forward neural network. Now let's talk about the activation function that we used in the multilayer perceptrons. So let's start at the output layer. If we have a multilayer perceptron for classification, we can use the exactly same activation function that we used for Softmax regression, namely the Softmax activation. If we only have a binary classification task, we could technically also use the sigmoid activation that we used in the logistic regression model. However, even if we consider a binary classification task, it's still common practice to use the 2 output nodes with a Softmax activation, and that is because just to make the coding a little bit easier and to implement a multilayer perceptron class in a more general form. So we just talked about the output activations where we use the Softmax activation for classification, but what about the hidden layer activation functions? For the hidden layer activation functions, we can also use a familiar activation function. Here we can actually use the sigmoid activation function from logistic regression, which is a classic. However, nowadays it's more common to use the so-called Renu activation function, and we will talk about that now. So Renu stands for rectified linear unit, and this is how the activation function looks like. On the x-axis here at the bottom, we have the net inputs, and then on the y-axis, this represents the activation function outputs. So what we can see here is that the Renu function almost looks like a threshold function. So it's 0 everywhere, the net input is negative. For the positive net input values, it returns the value itself. So on the right hand side, we see the mathematical formula for the Renu function. So as we can see, it returns z if z is greater or equal to 0, and it returns 0 otherwise. And this is also called a piecewise linear function. And below that piecewise linear function notation, you can see an alternative notation for the Renu function. And yeah, the Renu function is just one of the activation functions we can use in multilayer perceptrons. It's by far the most common one actually. However, if you are interested, we will share more resources on the different activation functions with you in the additional resource section. So now that we outlined the multilayer perceptron, let's talk a little bit more about the basic architecture and the design considerations of multilayer perceptrons in the next video.